Hello everyone, welcome to webinar on Midas Engine training sessions. Today's training session is on elevated RC water tank analysis and design using Midas Engine. I'm Nivedita Khole, looking after the technical support in Midas IT. If you have any questions during the session or after the session, you can write here at the questions box. We will get back to you at the end of the session, or we shall send you emails with the solutions. Today's webinar content is as shown here. I'll firstly introduce you to Midas Engine, its application areas. Then we'll have the demonstration on RC water tank elevated structure. I'll tell something about Midas support services offered. Then we'll conclude our web session with a special launch offer. And after that, we'll conduct question answer session. Please let me know if I'm not audible at the questions box. You can write yes or no. If I'm audible, please write yes. If I'm not audible, please write no. All right, thank you very much for your feedback. I'll move ahead then with some family program introduction of Midas offered by Midas. Midas has four main family programs. One is in bridges. Bridges, that means we have Midas Civil. Midas Civil is an integrated solution for solution system for bridges and civil structures. You can analyze and design simple RC slab structure, bridge, as well as complicated extra doors bridge, suspension cable stayed bridges in a very short time using Midas Civil. There is Midas FEA, which is an advanced nonlinear and detailed analysis system, mostly for research works. Then further coming under the structures, there is Midas Gen and Midas nGen, which are the integrated systems for buildings and general structures. We are seeing today Midas Engine capabilities. Then Midas Drawing is an auto drafting tool for rebar detailing and generating bill of materials. So the design results from Midas Gen or nGen can be taken into Midas Drawing to generate the drawings. And thereafter, we can also generate bill of materials. So that's Midas Drawing. And there is Midas Design Plus, which is a structural component design and detailing tool, a separate software solution. So you can have the design of individual beams and columns or footings like that. And also drawings will be generated for those designs and also bill of materials in Midas Design Plus. Then there is geotechnical family programs. We have GTS NX, which is a 3D software solution for geotechnical analysis. And there is SoilWorks, which is a 2D finite element and analytical software solution for geotechnical software. So that's about geotechnical software solutions. And then coming to the mechanical, there is Midas NFX, which is a total solution for mechanical engineering in structural mechanics and CFD. We have put it over here for civil engineering field because here we also need to perform the impact analysis, which can be handled by Midas NFX. Also, when it comes to 3D CFD analysis for bridges or high-rise structures, that can be handled by Midas NFX easily using 3D CFD analysis. Then further, there is Midas FX Plus, which is a pre and post processor for finite element analysis. Basically, you can have complicated geometry modeled easily using Midas FX Plus, and these models can be exported to all the Midas software solutions like NFX, Civil, FEA, Gen, nGen and GTS and SolidWorks. So everything is possible with the help of Midas FX Plus. All the software solutions of Midas family programs are well integrated with each other. So let's go ahead now to Midas Engine introduction. Midas Engine is the next generation solution for building, analysis, and design. It comprises of the analysis tool, the design tool, and also the drafting tool. All in one is nothing but Midas Engine. The most important concept of Engine is drawing to drawing. There is integration. All business processes can be integrated into one using Midas Engine. There is automation, wherein you can reduce production time significantly. There is optimization in the software, which can give enhanced optimized quantity takeoff. And further, the quality, high quality of design deliverables. That means you can generate good quality reports using Word documents with the help of Midas Engine. Coming to the application areas of Midas Engine. With the help of automatic automation, right, and optimization processes, it's easy for us to model such all these kinds of structures like apartment buildings, concrete frame with steel roof, car park and building, multi-towered structure, the shell type of a structure along with the frame structure. So these are few examples. Now let's go ahead to see how we can model our elevated RC water tank in Midas Engine. So mostly we are going to be focusing on how the modeling capabilities in Midas Engine. For those who have joined this session for the first time, the training sessions for the first time, let me introduce you to the user interface of Midas Engine. Over here at the top, we have ribbon menu, and this ribbon menu is divided into different tabs which are arranged as per the work procedure from left to right. The first 4 tabs are for modeling. Then we apply the load, we apply the boundary like supports. Then we perform the analysis, we perform the design, we check the analysis and design results. We can generate reports and generate drawings. And that's all. We are done with the entire structure from drawing to drawing. Coming to the tree menu, we have got over here 5 tree menus. First is the model tree menu, which gives the information about the modeling done in the workspace. Then further is the analysis tree menu, which gives information regarding the loads applied, the boundary conditions applied, as well as the analysis cases created. Then we have the design tree menu, which gives information regarding the design groups or design check positions, or if we have provided any parameters to the design members. Next is the display tree menu. Over here, you can have several views predefined. And for defining any view, you can simply click on the middle button of the mouse and click on this option right over here to save that particular view. You can change the color of your background from here by simply double clicking dark to light. Alright, so that's about the display tree menu. Then further we have the table. Table tree menu gives the table information, tabulated information regarding all the information, like all the information regarding the structure, the loads applied on it, the member parameters, also the mass boundary conditions applied, then the results in the results, the analysis, story, design results. So all these options are available, which we will be seeing after we are done with the analysis and design. Then further, we have the properties menu right over here. And this is actually a good feature in Midas Engine. What it does is that it can help us get the information regarding a selected member easily. And from here itself, we can do modifications for that particular member. So let's begin now with the modeling. Very important part before we start the modeling is the unit system. So we need to check the unit system at the bottom. I'm making it kilonewton meter for easy modeling. Further, we have modeling snap options here and auto intersect tool option on, orthogonal option on. So these are some CAD type of features available in Midas Engine. There are three modes that we can work on. One is a 3D, plane, and story mode. 3D is we can like select any or draw the structure in 3 coordinate systems. Plane as in we can draw in 2D, and story as well we can draw in 2D. All right, so let's begin now. We have right now conducted overall 2 sessions, right? So the first 2 sessions, the first session was in which we had seen how to use the grid lines using the for the RC for the steel structure. Then in the RC structure, we had used the tracing file import for modeling. And today we are going to be using the normal body type of sketching, and then we will be creating our members. Other than that, we also can create our model using importing functions, like we can have the Revit and Tekla files directly imported in Midas Engine using MGT file. You can have stat as well as parasolid files imported in Midas Engine. All right, so let's begin. Firstly, for my circular elevated water tank, it's an in-step water tank. So what I'm going to do is I'm going to be defining some stories so that I can work on the planes easily. It's nothing but creating planes for me. So firstly, a story set was created, and then the number of stories. So I'm going to be having 4 numbers of stories, and I'll give just a predefined value over here, which will be modified later on. All right, so first the height is going to be 0 to 20, and after that I want to modify the height. So the height of this level, 2F level, is going to be 1 meter, and after that it's going to be 4 meters and then 1 meter. All right, so the total height of my water tank from ground level to the top is 26 meters, and that will be okay. So now we can go at any level easily by using story. So we'll go to the story now. It's a circular water tank. So I'm going to be going on the roof level to create the top opening of my water tank. So I'll go to the roof, and then let's go to the body tab to start sketching our water tank. So firstly, we go to this body tab and use this circle option. We'll say draw circle with center point. We have the option to draw circle with 3 points if we have that information. So we have a center point. We select center point. It takes 0, 0, like it snaps onto the 0, 0. And further, we can specify over here the diameter, which I'm taking as 1, and pressing enter. All right, so that's my circle on the roof level. Then I'll go to the 4F level. And over here as well, I'll draw a circle with a center point. So this one will have, let me draw again. Yeah, so this one is going to have 8 meters as the diameter. All right, then further, let's go to the next level, that is 3F level. And again, we are going to be drawing the circle. So here, to go in and out of the command, we can press escape and space bar. So again, 8 meters. And then further on the 2F level, we will have another circle, which will be of smaller diameter, that is 6 meters. All right, and now 2F to 1F level, we are going to be having columns. So let's go to the 3D view to see now our circles that we have drawn. And let's go ahead, create the column. So the column is going to be created now from the front view. That's how I can easily create it. So I'm going to snap on to this point and further take it down. So it will be -3, that will go to -5, and further we'll make it -4. All right, and further this will be 0 itself, and this will be at -20. This is a relative value. Yeah. So this is -2, 0, and -20. It's a relative value to our node that we had first clicked on. And by pressing enter, we have created a body. So you can go to the 3D view and check it out. All right. Now let's go ahead and start creating our plates. So for that, we are going to be using really good tools available. That is Revolve, Sweep, Loft. These tools are really good ones to generate irregular type of shells or plates. So I'll be using this Loft type of command. And firstly, let me select the upper circle and then the lower circle. So as you can see, there is lofting done between two circles at two different levels. And after that, I'll click on apply. Similarly, I can click on this and extrude it. However, I do have these two circles, so I'm just going to go on lofting. Similarly, from this circle to this circle, apply. And that is it. Next, I would like to copy this particular column 6 times, or rather 5 times around. So total number of columns will be 6. So for that, we can go ahead, make use of rotate command. All right, so in this rotate command, we'll click on this dialog right over here, and we'll go for copy type of rotate so that we copy our selected column. So we select this column, and further we will provide over here the handle location. So this handle location is set to 0, 0, 0, which is what we want. And next is the angle. So I'm going to be copying 5 numbers of time at 60 degrees angle. And then we'll click on OK. So in this way, we have got all our 6 columns. Next comes the part of creating beams. So we can create those horizontal lines using this line type of body. So here we can see that the program is automatically snapping on 1/3 location of our column. So I'm going to be using that snapping and creating these beams. I'm going in and out of the command using the escape button. All right, so we are done with these lines. Now further, we also can go ahead create a face for this particular area. So for that, again, we can use this face command and we can select our circle and click on apply. And that's it. So now we have got lines and faces. Also, if you would like to create some braces at such locations, so we'll do that. We can go ahead, use line again and click on ends in this way. All right, so we have got our cross bracings. Now let's go ahead and do some intersection so that we will get arcs over here. Small arcs are very important to be created because we want to generate beams at the bottom, and these beams will be generated only for arc, not for circular line, not for circle body, because we need divisions so that the support so that there will be ends created for your beam. So you'll understand basically after I do the intersection. So I'll go for the intersect command now, and we can go ahead, select the objects like from here, select these objects and also these. There is no need to press Control. You can easily select all the objects using these tools. So all these objects are now selected. If I would like to unselect, then you can definitely go ahead with this part. All right, so now I'll click on apply. So we have got intersections done. Let me check with this. So we need to actually have body, circular body right over here. It seems that this circular body was deleted because of the face that we had created. So no worries, we can still go ahead and sketch our circle. So you can go to the plane mode, click over here, and yes, there is no body circle. So go to the center point right over here and create the circle. So we have our body line now, and we'll go back to our 3D mode, and then we'll go to the intersection command. All right, and we are going to be intersecting this circle, and also we will be intersecting that circle with the columns over here. So then we click on apply and escape to finish the command. So now we have got different arcs, as you can see in the yellow highlight, and these arcs will be utilized to be converted into beam type of members. So let's go ahead now and create the beam type of member. As you can see, this pink colored rectangle is nothing but the plane, work plane. So this work plane has been registered automatically by the program when you click on any of the surface. If you do not want to look at it, you can just undisplay the reference. Okay, now let's go now to convert our lines into members. So there is convert to member command. We are going to be converting our lines, which are called as curves in Midas Engine. So lines and arcs are called as curves in Midas Engine. So now you simply select. So I'll go to the front view and select all the horizontal body lines or body curves. And I'll select an appropriate section property, which of course we can define by ourselves. In the previous session, we had seen how to define the section properties. So that's why I'm not going into it again. So we have over here our beam section property assigned. Similarly, we can assign for the columns. So I'm selecting member type as column and the property will be as required. So here I'm thinking of selecting 500 by 500 as the property for the columns. So I'm selecting these columns in such a way. And then I click on apply instead of OK so that I can keep this dialog box open and use it for the further command. So I have got the columns and the beams. The next part is to create the shells or plates or walls for our structure. So here we have different members that can be used for a water tank. We can use plate type of members for horizontal members or vertical members. So we have got over here at the top, we don't have it at the top actually. Here we need to create one area. So for that we can simply again go to the face command and select this circle and click on apply. All right, so now we have it. Now let's go back to the convert member and we will go to the face and then see. So we can select the plates right over here like this. So vertical and horizontal plates can be selected. So this one will have the property of, let's say, 300 and I click on plus to apply. Then for the circular type of walls, we have wall type of element as well as we have shell type of element. However, the shell type of element will not provide us with design results as of now. It is available in Midas Gen and will soon be incorporated in Midas Engine. So we will use wall type of member temporarily to get the design performed along with the analysis. So we have wall type, and in this the analysis that will be performed will be based on the meshing plate mesh type of element. It will be a plate type of element itself. All right, so we will provide it with the thickness of 300 again and select the rest of our curved walls. So all these walls are selected and now we'll simply click on OK to finish with our model. So in this way, we have got our elevated water tank completely modeled in Midas Engine in a very short time using various functions available. So in such a way, you can have any type of irregular shaped structure modeled in Midas Engine. And that's because we have got this generating tools and there are modifying tools as well that you can completely make use of. Now after this, let's go back to the structure and let us use this story to auto-generate by itself because we have got divisions in between and we need to put all the members that we have just created into the story so that our design groups are generated. So let's click on this auto-generate story data and select the entire structure and click on OK. So it has automatically detected levels wherever the beams were and the rest of the levels are just the way we had provided. So we'll click on OK now. And then we can go ahead to the loading part. Okay, before we go ahead to the loading part, I'll just remind that we do have options in the member to directly draw the members like beams, columns. Right now we had converted all our body lines into members, but we can also directly draw beams, columns, and even the slabs and plates. So these options are available. Then further, we have the option to do the measurement, and you can even change the height of your members using the dimension command. So you can like click on dimension. It's just an example that I'd provide. And with this, you can simply, let's say 5 meters and click on OK. So in this way, you can reduce the height of any of the members as well, like reduce the length or depth of any of your member. All right, so this is how you can do easy modification of your model. Also, you can use this measure command to actually see what is the dimension, and you can keep these dimensions on your screen for your reference. All right, and if you do not want to see them, you can of course select and delete them. Okay, next is the check model. Check model will let us know about the duplicated members if there are any. So we'll click on check. All right, so it seems that there are some duplicates available over here. So we are going to be like looking at these, and we can simply delete those members accordingly. All right, now let's check. So there's everything's fine now, and let's see now what has happened. All right, so we have all our members over here now. Now let's go ahead. We can also use query to understand what are the members. So let's say I would like to understand about the walls that I have created. So this is wall number 2, and that's wall number 1. This is wall number 4 and 3. And further there is wall 6 and wall 5, and this is plate 2, and this is plate 1. So we can understand about the names by using this query information, and it will be displayed right on our screen. Okay, so we are done over here with our model. And now let's go ahead to the loading part. Okay, so in the loading part, firstly, let's start with self-weight. In the self-weight, again, we have got load sets to be created. So we'll go ahead and click on this toggle box to go to the definition of static load sets. So I'll make a dead load set over here for my self-weight, and I'll make a live load set over here for the pressure load. All right, so dead load and live load are done. Now I'll put this self-weight under the dead load set and click on OK. So we have applied the dead load on our structure, and we can see that applied with the help of this mark right over here. And we can also see, or we can also confirm if that load has been applied by going to the analysis tree menu, expanding the static load, and then expanding dead load dead load, and then looking over here as a self weight with a factor of -1. All right, next part is applying the pressure loading. So we have the pressure loading that can be applied on our plates and walls. So we are going to be applying a horizontal pressure load, like a vertical pressure on the horizontal plate right over here. So I'm selecting this plate and providing the value, pressure value of, we have a height of 5 meters and density of water is taken as 10, so 50. And I'll click on apply. So if I just want to look at this plate, I'll right click on it, click on it and, sorry, let's go out of the command first. Yeah, so click on it, right click on the screen and say show only. And now you can see the load that has been applied, the pressure load that has been applied on our plate. Right, so that's the thing. Next, let's go ahead and see the entire structure again. That is again by right clicking and saying show or hide all members. All right, now let's apply the water pressure on the walls of the water tank. So that's again using the pressure. However, over here we are going to be taking care of the live load. We had not changed the load set name for the vertical pressure on the horizontal plate that we just applied. So of course we can do the modification later on, and I'll show how to do that with the help of tables. All right, so first let's provide a choose a live load set, and select the objects on which we want to apply this load. And then this is just an example. So let me firstly create a function, because our pressure, like water pressure, is not applied like in uniformly from top to bottom. So we need to create a function for that. And here we have the option to create the function, which is nothing but linearly varying in the Z direction. So we go to the Z, and here we can provide the height. So we have the height from 20 to 25, and I'll click on calculate here. All right, so yes, instead of having all these levels, we can just have 20 and 25. And here we can provide the value of 50 and 0. So 25 is the height of the water level, so that's the 0, and 20 is the level of the base of the water tank, so maximum pressure is going to be, that is 50. So this is the function that we have on for our structure. We'll click on OK to finish with the definition for this function and close. And now to use this function, we are going to be selecting that function from here, and we have to take care that we provide a ratio, or you can say a pressure value of 1, which will be multiplied with the function directly. All right, so now we will select, let me change this to coordinate. All right, so here we are selecting over here the direction. Sorry, let's make it normal itself, so it will be perpendicular. All right, it's perpendicular to your plate. Now we will provide a pressure if it's positive or negative. It's going from outside to inside, so let me make it negative. All right, and after that we click on apply. Similarly, we are going to be applying our pressure. This is going to be in the positive, so we'll provide +1 value. Similarly for these locations, not this actually. So we have selected the rest of the walls, and then we'll click on OK. So if you would like to check this pressure load that we have applied, let's just activate these two members and right click and say show only. So we have the information shown right over here. Let's see the load values. To see the load values that has been applied on these walls, we'll click on this view control, and then we will click on we'll check on the load value. So after we check on the load value, you can see right over here how the loads have been applied with the help of the function. Okay, similarly we can see the loads applied on this plate. This is just for us to confirm if we have applied the loading correctly. And if you do not want to see the loading, you can just check off the static loads from here and say show all. Alright, so we are done until here. Now we will go ahead to the boundary definition. So in the boundary definition, there is support that we can apply to the structure. Alright, and for that we are going to be, let's say we are using the pin type of support for our water tank, and we'll go to the front view for easily selecting the bottommost nodes of our water tank structure, and we'll click on OK. So in this way we have applied the support condition to our water tank. Now we will go ahead to the analysis tab. And in the analysis tab, this is important for us to check about the analysis settings. Now, the meshing is not done yet. It's not required actually when it comes to Midas Engine. The meshing is done by the program automatically. So we can see over here the information regarding, or the control over the over the meshing of the plates or 2D elements. So even 1D elements. So as wherever you would like to have the results, like maybe you want to check the results of the beams at 8 locations. So you can provide division of 8. Then over here there is 2D mesh. So its length is 1. So you can just modify it to 0.25. Or you can also use seed control, like you can have the mesh size control at different edges. So that can also be done in the program. For now I'm just making a 0.25 meter mesh. Then if you have a solid element, solid structure, then you can do 3D meshing, control the 3D meshing as well from here. All right, and when it comes to 3D mesh, we also have mid nodes on geometry that gives us more accurate results. So this is about the mesh. Now, this is a very small structure that we have, but in case you have a really big structure, then of course the analysis time might increase. So to reduce the analysis time, you can make use of more numbers of processors, and you also use the GPU accelerators that can reduce the time for analysis drastically. So these all options are available for saving your time. Now let's click on OK and go ahead to the combinations. We can generate the combinations before performing the analysis, also after performing the analysis. So let's create the combinations before analysis right now. We'll just simply click on this auto generation and click on add. The program will generate load combinations automatically for ULS and SLS conditions. You can also create your own load combinations by simply providing a name over here, and then you can provide the load cases from here and the load factors for the load cases. So this is one way. I'll close this dialog box now for defining the load combination, and we'll go ahead to defining the load static analysis cases. So here we can click and we can see this is the analysis case dialog box. You can have as many number of analysis cases as you wish for performing different types of analysis or including different loads and different members. So this is possible in Midas Engine and is a very good strength in Midas Engine. So here you can like also click on OK and also go for the modal analysis. So in the modal analysis, we can go to the analysis control, and we have an advantage in Midas Engine that the program will automatically find a number of mode shapes until it reaches 90% of mass participation. So this is what we can provide to the program, and we can click on OK. So that is done, and now there are other types of analysis that can also be performed, like the linear buckling analysis. If you have the crane loading on your industrial structure, then crane loading is available. Crack section analysis can also be performed. So the crack section analysis usually is done when after you have applied the reinforcement. So we will be looking at it afterwards, after we are done with the design. So that is about the analysis. Now let's go ahead and run the analysis and check the analysis results. So Langso's iteration method is being used for the modal analysis for now. And we have got our analysis results right in front of us. So here we have the ribbon menu for the results and the analysis results tree menu. In the analysis tree results tree menu itself, you can simply go to different cases like dead load case, live load case, or combinations, and also eigenvalue analysis cases. And simply you can like say double click and you can see the contoured form of your result. You can also see the deformed shape. So this is the deformed shape of our structure. This is only for the self weight. If we apply only the live loads, let's look at the displacement. So this is the result for the live load. And further, we can also look at the results for combination. So we have FDLCB1, that is one of the load combinations generated. So let's look at the deformations for this load combination. So as you can see here, this is the load combination for this. This is the result for this load combination, deformation result. This deformation result can also show us value on our workspace. So you can check on this value, and this is the location where absolute maximum value has been reached. Now the result, you can see over here the legend, and this legend is showing actually 00 because the values are really small. So let's go to the unit system, and we'll see maximum displacement is 3.26. That's the displacement that we have achieved. All right, and also we can get different results like animated ones. We can have a cutting view as well. So in case you would like to check out what's inside the water tank, you can see the cutting view. That'll take us inside the water tank. So I'm keeping this cutting view right now. I'll click on add right over here and close this. Okay, and let's look at different results. Let's see the reactions as well. So we have the reactions, forces and moments right over here at the bottom. So all the values will be displayed after you simply change this absolute max to all. Okay, so I'm unchecking the cutting view so that we can see these values right over here. So 959.74 is the highest value. There is no moment at the bottom since we had not applied the moment constraints. Then we can also get applied forces on our structure at various node locations. So in case you require these results to use it at some other locations, then you can definitely take the advantage of Midas Engine. So that's one thing. Then beam forces and moments. Let's look at the results. We can see the actual forces. I'm unchecking the absolute the result over here. So yeah, as you can see, this is the result for the columns. The actual forces for the columns is really high. And let's take a look at the bending moment results. So as you can see, the bending moment results for beams would be higher, especially at the bottom of the water tank. So we can see high moments generated at these locations. And further, we can also look at the results for the plate forces. So this is bending moment in the X and Y. Let me look at the cut view. Okay, so we have the cut view right over here so that we can see what's going on inside. So actual forces, we can get shear force and the bending moment in X and Y. We can also get results for beam stresses like axial stress, bending stresses, shear stresses. Alright, now we are done with checking the analysis results. Let's go ahead to the design part. So for the design part, we will go to the design tab. And in this design tab, let us firstly start with the design settings. Before we go there, let me just make initial view of our structure without any cutting view so that it'll be easy for us to do the definitions in design part. Okay, so we are in the design part and we can go to the design settings. These are the general design settings where you can see which code to be utilized for performing the design. For now, we have Eurocode, American code, and British standard to perform the design. Next, let's go to the RC, and we can see over here the partial factors and various parameters that are required for members. Like if you would like to check the torsional strength for the beams, then effective length factors if you want the program to determine by itself, slenderness limitations. Then for the plate design, if you would like to perform flexural or axial plus flexural design. Then when it comes to a slab, for conventional slab design, we have one-way, two-way type of slab panel. Here, this one was performed in the last session for RC structure. Then further, we have the serviceability checks also available in Midas Engine. There is control, crack width check is there. Then further, there is deflection control as well. You can do the modification of the values over here by yourself. Then let's go ahead to the rebars. In the rebars, first is the material that we can define or we can state for the program to utilize. So this is like using the material, this material EN04 material. However, you can modify it to BS and you can change the main rebar grade as well and the shear rebar grade as well, so as you require. Then let's go to the rebar arrangement. The program is capable of providing the rebar arrangement as well. All you need to do is specify the cover spacing between layers. Then further layers, as in if you have double layer of reinforcement, then what should be the spacing? The default diameter for the main rebars, this is where in case of beams. Also, you can check these rebar arrangements right over here with the help of this path setting range. The program is going to be selecting out of these reinforced diameters and utilize it in the design purpose. So that's beam, then column right over here, braces, plates. You can select higher diameters as well and unselect the lower diameters for the main rebars, which maybe you're not using. Similarly, for the walls, I'm using the higher rebars over here for our water tank. and also for the shear I'm using high rebars. Similarly, we can have slab and foundation design performed in Midas Engine. So after this, we'll click on OK, and we are done with the rebar arrangement. Also, this is basically for all the types of designs that can be performed in Midas Engine. So the designs that can be performed are nothing but for beam, column, braces, plates, walls, and slab, as well as flat slab and foundation. Now there is alternate rebar information in case of slab and foundation. So we'll go ahead now to the checking control. So checking control is wherein the program can, by one glance, help us to understand if we have reached the target ratios. That means somewhere in between zero point 0.6 and zero point 0.9. So if this is the condition, if the ratio is in between zero point 0.6 to zero point 0.9, then the program will help us or tell us by saying OK. If the result, the ratio is going beyond zero point 0.9 but is still passing because it's below 1, then the result will be shown as critical. Then if the result is going below 0.6 ratio, then the program is going to tell us if you need to check because the member is probably uneconomical. So such kind of ratios we can specify to the program, and accordingly the program is going to help us with the status of our member. Like need check, okay, critical, not good will be like failing beyond 1, and failure is you need to probably modify the property of your member, like the section property and the material or whatever. So that's upon you. And not check is when any of the member is not being checked because of some reason. So you can actually understand with one glance if the design has been applied or not. So this is done. Now we can go ahead and create the design case. Before we go to the design case, let us firstly create the design group. In Midas Engine, we can automatically generate the design group. And this is important so that the drawings are also generated by the program. Once you are using the auto select function, you simply click on OK. The program will automatically detect the groups with the help of similar section properties and the material properties assigned. And also, if in case you are done with the reinforcement application, then it will also check with the similar reinforcements. So for now, depending on the type of member and the size of the members, the program has created the design groups. Then further, we can also check about some member parameters. So here we can select beam, column, subbeam, subcolumn, wall, and so on. We can specify the target ratio for a selected member. So basically, the design settings that we just saw can be modified for a particular member with the help of member design parameters command. All right, now let's go ahead and create a design case. In this design case, again, we can have multiple numbers of design cases. For each analysis case, a separate design case, or for one analysis case, we can have number of design cases wherein we can simply select any particular member and perform the design. So this is the thing, we are selecting all to perform the design, and now we'll go ahead and run the design. We'll ask the program to provide us with the arrangement automatically and click on OK. So the design has been performed, and at the bottom where there is a message window, we can see there is 0 error and 0 warning message. So we are good to go ahead and check the design results. So let's go to the strength check first and look at the status of the design. So as you can see over here, the green one is for need check. That means this is passing, and also is below the 0.6 target ratio. That's the minimum target ratio. Then we have critical result, which is in yellow. This means that our result is from 0.9 to 1. Then we have got over here these walls which are failing. These are not good. That means they are going beyond 1. And further we have blue is okay. So we have got beams which are within the target ratio limits. And there is these columns are there which are again critical, and further we have got beams which are below the minimum target ratio. So let's go ahead now and look at the design results separately. So firstly, from the design tree menu, we can expand RC and we can see the result for the beams. So here we can actually see what is the ratio separately for the bending in the negative direction, in the positive direction, and we can see the ratios over here in the legend. So you can see that right over here. Then let's look at the shear ratio, what has been achieved. So everything is actually, these beams are passing, so it's all 0.78, all below 1. Then if there was torsion check, yeah, torsion check was not checked on, so it's not giving us any value. Then we can also look at the compressive stress values, stress ratio, positive, negative, and we can look at the tensile stresses in the beam with the because of the reinforcement that has been applied. Then cracking check, crack check. So crack check has been performed. We have same value for the crack check, it's 0.43 for all. And that's the negative, and then we have positive values as well. Then deflection, there's short-term as well as long-term deflection check. This is long-term deflection check, so we have everything below 1. Then we can also look at the area of reinforcement required, the negative and the positive reinforcement. Same thing, rebar ratio and creep. So these are the results. These same results can be seen for all the members, like the column members we have, and also we can see the results for the plates. So we have the ratio for the bending of the plates, and we can also see the result for the walls. So these are the results for the wall type of members. Okay, so let's go ahead now and let's take a look at how we can get a detailed design report generated for our members. So for that, we'll go to the design and we will click on detail, and we can click on any of the members to see the result for. So let's say we're looking at the column and we'll click on apply. The program will create a Word document as a detailed design report. This is the rebar arrangement provided for our column, and we have for the results right over here. That's about the results. Then we can also see the rebar arrangement with the help of RC sections. This is a design modification dialog box. You can actually do the modification of your member sizes, section sizes from here. Also, you can change the reinforcement from here directly, and then you can see if your section is passing or not. So for example, if I make this as 500 by 300, all right, and I choose to have 3 numbers of bars, and I want P16 instead of P20. Okay, now let's just click on this design modification member list and see if this is passing. So yes, it is passing, it's fine. The ratio is actually further reducing. So this much of reinforcement is actually not required. So basically you can do the modification of the reinforcement as well as the section sizes from this dialog box itself. This result, as you can see, is for property based. We can also see the result for each and every member by clicking over here. Similarly, we can see the results for the columns, we can see the results for the plates, and we can see the results for the walls. All right, now we will go ahead to the drawing. So here we can report in drawing. So report generation is done by the program very efficiently. Can click on new to open a report maker in Midas Engine. And here you can simply start with providing the information like the cover, and then you can create chapters, and then in these chapters you can choose what information you would like to provide. For example, the column list can provide the wall list by story, then the beam and girder list and the plate list. So these are the elements. Then further, the load case list, load combination list is more common, so I'll put it into another chapter actually. So we can add one chapter, right click and add. I'll provide a name to this chapter. Basically this is about member list. All right, and this one will be regarding the load combination. So that's done, and drag and drop the load combination from here on this, and also any other loads that you have applied, like the pressure load table. You can also provide over here the other information. So let me add one more chapter. This chapter will contain the support conditions. So I'll write over here support, and further let's look at the beam forces results. Put it under another chapter. It's very easy actually to work in this way because the information is already there. You do not have to go to the model and then take that information. All right, so that's the thing. Then further you can also find from here which of the analysis cases it's using for giving us the results. All right, now once you have put all the items over here, then we can go ahead and click on generate all. So by clicking on generate all, the program will start creating the entire report using all the information that has been taken from the model. So you have your image of the model, then the member list, what all members are there, the load combinations, and further these are the support conditions applied. So you can see over here with the help of table, and then further the results for the beams. So these are the different results that you can put it into the report maker, and after that you can simply export this into a Word document which will generate a Word file. So you save it and click on OK. So Word file is opening right now, and you can see over here how efficiently the program has created the entire report, which can be directly utilized. So I'm closing this now, and let's go ahead to see how the report drawings are generated. So firstly we can look at the settings. Here we can find out what all column layouts are going to be used by the program. You can do the modification. Maybe you can take the level 20, and over here you can take the start level as level 6.6 as you require, and then go to the plan. These are the different plans that will be taken by the program. Then the rebar arrangement for every floor location will be taken, and after that you can just simply click on OK. After that we'll just click on generate drawing, not double click, just once click, and Midas drawing software solution, which will be installed along with Midas Engine itself, will open up. So we have Midas drawing software solution in front of us. Now we will go to this drawing creation menu bar and menu in the menu bar, and then we will go for the settings of the structural drawings, wherein we can set every information that we require as our drawing are going to get generated depending on these informations. So this information. So we have display information, scaling of the marks, and detailed settings for different member types as well, like the rebar positions and the legends. And hatch patterns also you can decide by yourself. And after that, we'll click on OK, and we'll go ahead to generate the drawings. So firstly, I'll generate a structural plan. So we can go to this floor plan and we can generate one of the floor plans. So I'm generating over here the 20th level floor plan, and I'll click on confirm. So whatever is selected is going to get put over here, and this is how we can see. Then also let's look at the elevation. So firstly, let's create over here a section. We've specified a section name 1, and we'll specify the starting point. I press F8 for going straight down. And we'll click at the side. So this is how we can see the section that we had just selected from here. And also we can see the beam list and the wall list. Then further, let's go to the member list, and we'll click on confirm to see the information for the design results. So for the column, different groups are created, and for those different groups, the column arrangement, rebar arrangement, and sections are shown. And accordingly, we can see over here the reinforcements and reinforcement information. Similarly for the walls, 10 at 400, 13 at 400. These reinforcements can be edited in Midas Engine itself. This is how you can see the beam section list with the reinforcement. And that is it. So this is about the drawings generated in Midas Engine. Get back to our software. If you have any questions, please let me know. All right, then I'll go ahead in the presentation and let you know about the support services that is offered by Midas. We can conduct such kind of webinar sessions for individual companies as well. And you can also go to our website, wherein training with the help of videos is possible. Let's conclude our session. So here we can understand that with the help of a simple modeling feature, there is integration of shape model and the analysis model. Because of many automated features in Midas Engine, there is auto generation of structural model, and mesh is also automatic. Need not worry about the mesh size at all. And further, there is optimization performed by the program for steel as well as RC structures, after the design has been performed. And we can also generate high quality outputs like we saw with the help of report maker and the drawing. With this, I would like to go ahead to the last part, that is the special launch pricing of Midas Engine. So you can basically get the Midas Engine software solution for creating your structural drawings out of the architectural drawings, wherein you can have your modeling, analysis, design, reports, quantity takeoff done all in one software solution. And everything you get it only at a launch price of 1,200 US dollars. We have original price for a yearly subscription of 2,400, and you're getting it at a 50% off price, that is 1,200. So it's like on an average 100 US dollars per month only. However, this launch price is available only till 31st of March. So you can make the most of it before the offer gets over. All right, we have some questions over here. Okay, so one question is, how can we see the mesh generated by nGen? So yes, I did not show that. However, let's see it. So we have this display mode mesh, and here we can see mesh edge. So this is how the meshing has been performed by the program automatically. It has taken care of optimizing the mesh size and also taken care that all the elements are properly connected with each other. Even though it's a member-based modeling in Midas Engine, it is taking care of the analytical, or not analytical basically, but finite elemental analysis importance, the importance of proper nodal connectivity. So that is all maintained internally by the program itself, and you can also see it after the analysis has been performed. All right, so another question is there, what is the difference between column and wall column? So column over here in member, let me go to the pre-processing mode. So in this, Midas Engine has got column and wall column type of members. So column is a 1D element and wall column is a 2D element. So wall column will behave like a long wall connected with a rigid beam at the top as well as at the bottom. So this is used when you want to actually apply the uh, like loading on the edges, like at one edge of a long wall. So for that you can utilize wall column. Otherwise, if you have just column member, then you need to apply the connectivity at the center of the column or wherever is the location of your line element, the center of your line element. Another question is how to generate the wind load automatically. Well, we have the load, and in that we have wind load option. So we can firstly create a wind load function over here, and based on the codes we can define the wind load. So you can select the code, and you can specify over here the range, like this is in mm. Let me firstly change it to meters so that I can easily put the information. So there is wind load function definition. We'll go to range, which is 0 to 26, and accordingly we can provide the rest of the parameters, and after that the structural factor can be specified, and the coefficients can also be automatically calculated by the program. You can provide the information about the breadth, which is same 8 meters itself, and you can have the internal roof friction, all these types. So depending on how your structure is, you can create the function, wind load function. Click on OK, and after that click on OK again, and then assign this wind load function to your structure. So you can have the wind load function selected for a general type, or an equipment open area type, or any equipment type of load, and there is story based as well. Right now I had actually created for enclosed area. However, we can apply the loading on this structure, on this kind of a structure using the story, or you can apply it using the equipment type. So you simply can go over here and then create the wind loading for the building type. So that will automatically take all the information, select it, and click on OK. So in this way you have applied the wind loading to your structure. Another question is that can we draw the ramps in buildings? Yes, we can. We can simply use member option over here, member type of command, in which member tab over here, and then create plate elements, a long plate element for your ramp by clicking on the corners of your ramp. So that's how you can create the plate. You can also have, you can sketch the perimeter of your ramp using the body and create the plate in between. All right, another question is that when it comes to a high-rise structure, which shear wall can be used? Well, for a high-rise structure, it is recommended to use the wall plate not mesh type of a shear wall. It's actually, it can help fast analysis and provide you almost the same results that of the plate mesh type of wall. So this wall plate type of member is actually like a wall column itself, and it can you can actually get the results at the top and bottom of the wall, and also you do not have to like go for long time analysis, and the program will take the in-plane as well as out-of-plane forces for this type of a wall. Yeah, we can have a section drawing of the water tank. We need to create that section first of all, and then we can go ahead with the drawing generation of it. All right, if you actually are also comparing with Midas Gen and nGen, then it actually depends on what kind of a structure you're creating. So Midas, if you compare, then Midas Engine is actually having a huge variety of ways in which you can create your structural model. So it depends on the usability also, and depends on the type of structure you're creating and the different functions that you're utilizing to reduce the time of your modeling. Again, another question is, can the program calculate long-term deflection for beams and concrete slab? Yes, that's what actually we can get in the design part. So if I run all, then in the design tree menu itself, we can get the deflection result. That's the serviceability check that can be performed by the program. All right, so here we have our RC and for the beam, and there is long-term deflection check. All right. I suppose all the questions are answered. If you have any more, then please write over here. We will be ending the session now. All your questions, the remaining questions will be answered by email, and all these questions which you have already asked and I have replied will also be documented and will be sent to you. The video is also being recorded, so you will also get the recording of the session. All right, thank you very much for attending our webinar session. The next webinar session is going to be on Monday, so see you then on Monday.